Hey everybody, it is me, Steve. It is still April 24th, 2019. Is 7:40 out, and it is Geo-Rant time, Geo-Rant 103. We're still talking about unconformities. Quick summary, just to show you, we are going to talk about this. These are the three main types of unconformities. Now, you may have seen, I'm going to talk about a subset of each of these, okay? And you may have seen in the last one this, which I did not talk about, which I'm going to address here. Remember, an unconformity is some amount of missing time in the rock record where either non-deposition, erosion, something happened where the rock record was not preserved, okay? So, this is a fault, an angular unconformity. I didn't draw it here. I drew all these, but you could have, this is a reverse fault. So compressional forces push the rock together. So you could have a bending of rock here, and you could have a drag fold here formed by this reverse fault. Okay, you see it? I'm trying to get it in there. Sorry, the camera's okay. So you could have had that, some sort of angular relationship between beds, and you still kind of technically have one here. But a fault is not an unconformity. It is just a contact, although an unconformity is a type of contact. Why is it not an unconformity? Because there's no missing time. A fault is a single, well, not a single, but essentially in geologic terms, it's an event. They are formed by an event, okay, that postdates all of this, all right? So the deposition of all these rocks. So it, in and of itself, is not a type of unconformity. It's just a type of contact. Well, we do have other types of contacts within these three main types. Like we have a buttress unconformity and an angular, which is a type of angular unconformity, all right? Okay, that's when younger strata are deposited up against older strata, influencing the bedding of the younger strata, okay? Like what we call initial dip. Most rocks in the rock record on the surface are deposited in relatively horizontal layers when they're first deposited. And then through tectonics and motions of the Earth's crust, they become deformed, tilted, and angled. There are some that have initial dip, like alluvial fans. Like if you go on a mountain range, like in Death Valley, this is common. You get high topography and then a steep drop to valley, you'll see these alluvial fans, just fans of conglomerate and sand at, where streams have dumped into that valley, and that will dip like this. The Copper Harbor conglomerate up in the UP is an example of something with initial dip, but that is not a buttress type conformity. But there is one in the Midwest, and it's a place I've taken you to before called Baraboo, Wisconsin, and Rock Springs is an excellent exposure of this, and this is what this is kind of modeled off of. Okay, you see this would be the Baraboo quartzite. These are the older layers, these are the younger layers, as we know. And the north limb, which would be Rock Springs, it was tilted nearly vertical, and that's all Precambrian. And here's your unconformity, this jagged darker line the red arrow is pointing to, and then you see this like brown layer conglomerate, and then you see this orange sandstone, and then you see this green limestone. Well, the conglomerate's equivalent to the Parfreeze Glen, and as you can see, the individual beds within here have an initial dip. They are not horizontal. The beds are angled, influenced by this being a paleo high. Paleo topography was present when the other stuff and the Cambrian stuff was deposited. So we had some paleo topography. So that's what happens. It creates kind of an initial dip. All right, so that is an example of a subset of angular unconformity. Now we're going to talk about this, a ParaConformity, which is also known as a diastem. I shouldn't have put diastem in parentheses. I should have just done it in a different color, which is a type of disconformity. So here is what it looks like. These are really, really hard to pick out. And the red line is pointing, or the red arrow is pointing to the dark line. Now, these are level, parallel, horizontal strata, whatever you want to say, where no apparent erosion has occurred between level beds. But there's just some amount of missing time. All right? We don't know what that missing time usually is, but we can pick it out by, like, I remember in the last one I said bedding planes can kind of, are technically unconformities. They're just such a small amount of missing time we don't care. These are like right above that level. okay? And you can actually, and in the original, the actual disconformity, sometimes you can get corrosion surfaces like this. But this case, there is nothing like that. Deposition ceased for whatever reason, but you can pick it out because you had cross-bedded sandstone here. Then you get this thin lamination. This is really common in the shale partings in the Mississippian, Silurian, and Devonian throughout the Midwest. But you'll get like some sort of, you know, posits here, in this case cross-bedded sandstone. You'll get just like a lamination of shale, and then you'll get a deposition of some other rock unit above it. In this case, it's shale. It's a shale. So this would be like a thin bed of siltstone, actually. Okay, so that's how you'd recognize this ParaConformity or diastem. It's just a break in time, or sedimentation might change for whatever reason. Say this was a carbonate like a limestone, and this has stopped being deposited. You had clastic influence, you get a thin bit of clastic influence here, and then you get more limestone, and once the clastic influence ceases. So that's a type of disconformity, is the ParaConformity. These things, like I said, are really hard to pick out. Usually takes specialists, somebody who studies that all the rocks are the same age in an area, to pick these things out. You know, if there's a thin shale parting between carbonate units, that's kind of an obvious one. That's about as obvious as it gets. Otherwise, these things are practically impossible to pick out. So, okay, let's get to another one, a nonconformity. What's a subset of nonconformity? It would be an internal unconformity. Okay, and that's what I have depicted here. Here, red arrow, and this is going to be a little harder to follow because this unconformity follows this pink unit, then this gray unit. So this pink unit would be your plutonic rock, and this gray unit would be like your dikes and your sills. So it's a little harder to follow, because it's not just one line from side to side. But you can see here, because what happens is Pluton intruded this green rock, okay, and then the Pluton, before it cooled, injected some sort of sill and dikes into the country rock, the surrounding rock above it, the sandstone and the limestone. So it forms this unconformity all around it, because there is missing time. This green, this white, and this yellow layer were deposited before this Pluton came in, and before these dikes were intruded. Okay, so there is some missing time, okay, involved. So it is an unconformity. And you can see here I have this kind of red hue around the edge of the whole thing. All right, that's how you would recognize something like this. That's what we call a baked zone. Okay, so these are created when some sort of igneous body or hydrothermal fluids intrude into the country rock and alter it, creating baked zones, and in some cases skarn. Okay, which would probably, in an intrusion like this, you could get skarn right around where the yellow carbonate rock is. Okay. So that's how those form, and an example of these would be the Keweenaw dikes in the UP and in Ontario. Okay, that's an example of those. So I think I'm going to wrap it up here. We're coming up on 8.5 minutes, but you know, here's your basic one type of unconformity I showed you in the last video, and here is a subset of that one. So your angular unconformity, you have a buttress. And here you have a disconformity, a subset of that, which is your ParaConformity. And then you have your nonconformity and your subset of nonconformity, which would be internal unconformity. Anyway, that's it. If you have any questions or comments below, please leave them, and I hope you learned something.